Hello and welcome to another video in the Administration of Operating Systems course. Today I will be going through slides for lecture 2, the Linux file system. This is not a full-fledged lecture, I will only be highlighting some of the more important aspects of this topic. Therefore, it is important that you pause this video often and take your time to understand the concepts I'm talking about. Preferably, you will also apply a lot of this information on your own, experimenting with the Ubuntu virtual machine you should have installed by now. In general, a file system is a set of data structure used to organize information. On one hand, this information is stored in some particular way on some kind of device, for example a disk, and the organization there depends on the technology that's used to manufacture this device. On the other hand, you have the high-level view that you would like to present to your applications and your user. In general, you would like this view to be hierarchical. You can think of it as some kind of family tree where you have some ancestors and some descendants. And this is a very nice structure because it allows you to have a lot of information organized in a pretty nice way. It's very natural for humans to look at things this way. So a file system hierarchy can look very similarly. You have some files at the ends of those paths, and you have some directories at the branching points. There are different types of file systems that they have their own names. So NTFS is a default file system for Microsoft Windows operating systems. ext, 2, 3, and 4 are different versions of the most common Linux file system. In Linux file systems, a directory is just a special type of the file. It doesn't have to be like this. Some other file systems are organized differently, but in this particular case, a directory is just a file which contains entries for all other files, as well as subdirectories. And each such entry consists of the file name and a number called the inode. And inode is used as a pointer to the physical location of data on the device. We will not go into too much detail about how it's actually organized in this lecture. Hopefully we'll have time to look at it a bit more deeply in the future. But for now, this is enough information for you. And each directory, even if it's so-called empty, contains at least two special names. It contains a single dot, which is a pointer to the directory itself, and it contains the double dot, which is a pointer to the parent directory. And actually turns out that this is enough to represent the whole structure. You don't need any additional information about links. And from application and user point of view, each file and each directory has a name. This is the most important thing. You call it file name or directory name. And the constraints on what is allowed as a file name depend on a particular file system type. The interesting thing is that at least in Linux, you can have several different file system types within a single file system. So you can have part of the tree being ext2 and another part of the tree being, for example, NTFS. And that means that some of the file names that are legal in one part of the tree would be illegal in the other one. And also within a given directory, names should be unique because names are the only way you have to access the data. But typically, it's not really the file systems that enforce it. It's only the operating system that enforces it. When you create a file, it first checks that there is no file with the same name. And if there isn't, then only then it allows you to create a file. So if you get low-level access to the device, you can actually fool file systems very often and create several files with the same name. And then depending on the details, this can be more or less confusing to the operating system. But it, for example, can be a pretty interesting way of hiding information because it will be really hard to access this information unless you know it's there. As far as file names go, you can typically use most printable characters, but there are some which are safer than others. So letters, numbers, underscore, period, and comma are always safe to use. Some of the characters have special meaning, for example, space, star, question mark. So if you use those within the file names, then they will be interpreted by the shell as they have special meaning to the shell. So if you want to use them as part of the file name, you have to quote them either with quotation marks or with backslash character. So if you have a single file called my file and you want to print it, that's how the command would look like, or you could use this one instead. File names in Linux are case sensitive, and modern Linux file systems allow you to have file names of 255 character length. That's not always the case. Another important concept is the path name, and path is a series of names that identify a path along file system branches from one file to another. So a starting point is always directory. There is no point in starting a path at a file because you can never go any deeper. And it's important that in Linux, path components are separated by slash, not by backslash, as you may be accustomed to from Windows. And the reason why path name is important is because it can be used to uniquely identify a particular file or directory. If you know a path name, you know to which file or directory it points, at least assuming that you know the starting point. It's also possible that the path name does not lead anywhere. If you, for example, remove the target, then a path name which used to be valid will be now invalid. That can obviously happen. And it's also important to know that in Linux, there can be several path names that refer to the same physical file, and those are called links. So you can have the same information being accessible from different points in the file system hierarchy. Again, we will come back to this idea. Typically, a file name also contains something called extension, which is just the part of the file name after the last dot. And by convention, extensions help describe the contents of the file. So you could have a program written in C programming language, C++ programming language, a binary which was compiled, and so on. And the conventional file name extensions can be used to see it. Or you could have a memo as a PDF file or PostScript file, and you would distinguish them by the extension. It's also very common, especially in Windows, that you use extension to deduce the default action that should be performed of the file if you double click it, for example. This convention has been to some degree adapted into Linux, but it's not as common. So for example, in a lot of labs that you will be doing, the default shell like bash does not use extension to figure out what to do with files. Although you can, for example, use extensions to guide things like file name completion. Again, this is a bit more too complicated for this course, but if this is something you are interested in, you can definitely find information about it on the internet. The important thing about Linux file system is that it's rooted in a single point. So there is no concept of drive letters as in Windows. There is always a single file system root, which is the shortest possible path, the single slash, and all the physical drives are within the same tree, all the hard drives, all removable media, network drives, and so on. And that makes it really easy to define parents and children. Basically, all the directories that are closer to the root are parents, those that are farther away are children. And as I mentioned, there is this concept of links, which actually means that Linux file system is not necessarily a tree. A Windows file system is always a tree, but in Linux you can have a file system which is not a tree. You can have cycles in it. And well, depending how you look at it, it allows you to do a number of interesting things, but it can also be a problem in some cases. There is also a concept called hidden files, as you can see. Actually, I was just joking. Hidden files are files whose file name begins with a period. And this is a convention that most tools, for example ls, which lists files, will not display such files unless specifically asked to. In file systems like NTFS or FAT, hidden is a file attribute. In Linux, it's just a name of the file that defines this. And you have already seen some of the hidden directories. The period and double period, those are hidden entries. They appear in every directory, as we mentioned. And those files can be displayed when you specifically ask for it. For example, using ls-a command will display files like this, while regular ls will not. Here is an example of how it works. And now, if you haven't paused the video ever before, now would definitely be a good place to pause it. Try this command and this command in your virtual machine. See the difference, and hopefully it will make it a lot easier to understand what happens. So hopefully by now you have figured out how to access what we call command line interface. So you can do it, for example, using the terminal in the Ubuntu system. Command line interface is a mechanism for interacting with a computer by typing commands to perform specific tasks. So instead of using mouse and clicking, you only type what you want the computer to do. So it's text only, it's typically line by line. So you type one line, press enter, computer executes whatever you told it to do, gives you the results, then you type another line. And well, it obviously uses less resources than graphical user interfaces because you don't have to put all the pretty pictures. It's clearly more difficult, especially for beginners and occasional users, because first of all, you get less feedback from the computer, and second, there is no clearly visible presentation of options. So you don't really know what you can do. You have to, when you see an interface of a graphical user interface program, there are some buttons that you can click. If you don't know what to click, you just find the button that looks like something you want to do, you click it and see what happens. In command line interface, you have an empty line and you can type whatever you want. That doesn't really show you what are your options. On the other hand, for expert users, command line interface is often more flexible because it allows much tighter control over environment, which leads to a lot more powerful automation capabilities. So you can combine things much more easily, you can repeat things much more easily, and you can do more complicated stuff without worrying about some of the graphical user interface problems. We will look at that basically through the rest of the course. So in general, the shell reads commands one at a time. So you type something, press enter, and then computer tries to execute it. And everything until the first white space is a command name. It can be either the internal command or the program that you want to execute. Afterwards come command arguments, separated by white spaces. So you can have multiple arguments, and everything is separated by white spacing. This also shows you why spaces in file names are bad, because then computer doesn't know if it's one file with space in the name or if it's supposed to be two different arguments. And again, some characters have special meaning. We will come back to this later in the course. Some more basic information. Each command starts at the command prompt. So you typically will see something like this. This is an indication that the shell is now ready for your next command. And the important thing is that if there is no such thing, it means that the shell is not ready. So it's doing something. And if you don't know what it's doing, you have to look at what happened before and try to figure out what's happening. There is very little reason to try to type commands if you don't see appropriate command prompt. And when you tell computer what to do, you specify command name, options, and arguments. And options and arguments depend on a particular command. Obviously, depending on what you want to do, you have different options that you can specify. And options and arguments can but don't have to be optional. There are some commands which have mandatory options and arguments, and there are some which have optional command options and arguments. There are some common things about how command line operates within GNU operating system. So typically you have two different options. You have short options like -a and long options which have -all. So those are obviously easier to type if you know them. Those are easier to remember if you don't use them all that often. Most commands have the -help and -version options, for example, if you want to find something that's common to a lot of different commands. Before we go deeper into using different commands and what kind of programs you will be working with, the important concept is the working directory. It's basically the directory in which you are kind of considered to be in. And in Linux, it's associated with every process, so in particular with the shell process that you are running. There is a command called pwd, which stands for print working directory. And as you can see, people who created Linux and Unix before and so on really liked the short, really didn't like typing, so they used the shortest possible command names for a lot of things. So the pwd utility displays the path name of the working directory. So if I'm in here and do pwd, it will tell me exactly where I am. And it's a good idea to always be aware where you are. A lot of problems that students have in the course, during labs, and so on, come as a result of thinking that you are in a different directory than you really are. Because most utilities, unless you tell them otherwise, will operate on your working directory. So it's important that you know where it is. Another important directory is the home directory. Every user in Linux system has their own home directory. So this is the directory where you start after you first log in. This is also a directory where you have permissions to create files. Very often you don't have permission to create files in very many places. You can do it in your home directory and maybe in a couple of others, but that's it. This is also a directory which contains a lot of configuration files for utilities and so on. Now that you know a little bit more about those concepts, we can come back to the idea of path name. So again, path name is a series of names that trace a path along branches from one file to another. And the idea is to identify a particular file or directory. And there are two kinds of path names. The ones that start with the root directory, so start with /, are called absolute path names. And they always uniquely identify a particular file. If you have a path name that starts with / and ends with some particular file, that file is always uniquely identified. There is no doubt about what file you have in mind. Now, every other path name is something called relative path name. So they are assumed to start with dot, so current directory, and you can omit the leading // because it's clear that that's what you mean. And those identify a file if and only if the current directory is known. So if you are in a particular directory, a relative path name is uniquely identifying a particular file. But if you change your working directory, the same path name will now identify a different file. So if you think about something like this, depending on where in the file system hierarchy you are, this will point to different files. So this is very, very important to understand. So here is an example of how it works. You can have absolute path names for all of those things. Each of those is the absolute path name. It starts with slash, and it basically tells you how to get from here to a particular place. Now, if we come back to this idea of family tree, this one is significantly different. This one doesn't have absolute path names. All those people are identified in relation to you. So if you think of this as your working directory, this relation and this relation holds, but if you change here, then some of those relations are different. So this is an example of relative path name. And this is a path, again, from working directory to a particular file. So this depends on the working directory. If you change the working directory, the relative path name will change as well. You can think of it in two different ways. So the same path name will now lead to a different file. Or if you want to reach the same file, you need a different path name. And the simplest of the relative path names is just the file name. So if you have just ABCD, this indicates file called ABCD in the working directory. Similarly, files that are children of working directory can be referenced easily. Grandchildren can be referenced relatively easily. So it's basically just two names. So whatever is the subdirectory and then the file name. And it's important that you choose your working directory properly for a given task, because then the path names that you have to write will be significantly shorter. So here is the same example as before, but now all those path names are relative for this kind of working directory. And again, you can think about how it would look, how those things would change if you moved to a different directory. There is one special character, the tilde, which is also commonly used, which is important to know about. This is a special form of absolute path name which always expands into the current user's home directory. And now that we understand how the file system hierarchy works, we can start talking about the basic file system utilities that are available in GNU Linux operating system. So there is a lot of small utilities that you will be using during this course. Some of them are very simple, some of them are very complicated. And as I mentioned, we will be using command line shell as a way of combining those different utilities to do whatever we want to do. Today we will focus on the basics. The combining will come on future lectures. Again, the thing to remember, I mentioned it before, you use command name followed by command options and then followed by command arguments. In this order, and you separate it by spaces. So here is an example. There is a command called ls, which lists files, and there is a lot of different options that you can use. Again, now would be a very good idea to pause this video, try those things on the virtual machine, see if you understand what's happening. And again, if those things that start with the dash or minus sign, those are called options. They modify, in general, they modify how the command operates. And those things that don't start with dash, those are arguments. So they basically tell the command on what kind of objects should it operate. So -L means that the command will list files in so-called long format, so printing a lot of information about it, not just the file names. And ABC here means that you just want the information about this particular file. You don't want all files, just this one. Another command, make directory, mkdir, not particularly complicated, although there is a number of things you can try. Again, you can just look at this information here and try to understand it, but it's also a very good idea to try to do it on your own, see what happens if you get the same results. If not, why not, and so on. Command options, this is something I've briefly talked about. Change directory, pretty important command, cd. Contrary to the name, it doesn't really change the contents of the directory in any way, it just changes where you are. This is not necessarily intuitive immediately. Some more examples of how cd works. Again, I've talked about the dot and double dot directories before. They don't come up or they don't show up on their own. It's just the make dir command that automatically puts them in each directory that it creates. And obviously those entries are always hidden. They start with a dot. So if you just try to do something like this, cd dot, you will stay in the same directory. If you do cd dot dot, you will go to the parent directory. There is command remove directory, rmdir, which, as the name suggests, deletes directories, although it requires the directory to be empty, except for the dot and dot dot entries. There is also rm command, which is a more general one. It can remove both files and directories. And it, for example, has the -r option for recursively deleting stuff. So it will delete the directory and everything below it. So use that with caution. You can lose a lot of data if you make mistake here. There is a command touch. There are mv and cp commands for moving or copying files. When we talked earlier about special characters, I didn't really tell you what they mean. So 3 of the special characters or 4 of the special characters I want to talk about are star, question mark, and square brackets. And they are used for something called name matching. They are wildcards. So they can be used with a lot of commands, especially ones that operate on the files. Although not only, you can use them basically with almost any command. The idea is that they allow you to specify a set of similar names. So you can match anything or a single character or something within a range of characters. So here are some examples of things that you can do. And again, try to use them on your virtual machine. Try to see if you understand what they do and then apply that and see if the results match what you expected. On a more general level, there is some kind of hierarchy standard that describes what are the main directories within Linux file system and what is supposed to go there. So here is how the file system hierarchy standard looks like. There is the root directory, and below that is a number of common directories that you will find on a lot of distributions of Linux. So the idea is that you want those to be reasonably standardized so that when you move from one system to the other, you know where to find things. And I will not go through them in detail. They are described in the book, what they mean. But it would be interesting, or it should be interesting to you to, again, go to your virtual machine, see which of those directories are there, which are not, what's the contents of each of them, try to understand what's the idea behind that kind of hierarchy. Another aspect of the file system which is important to understand early is the file permissions. Most modern Linux systems support two different ways of specifying file permissions. There is the traditional Unix way and there is access control list. And the traditional Unix way, you can see, for example, when you do ls-l, it specifies what are the file permissions for this file. And if you look at it, the first thing here is the type of the file, then there are permissions and some additional information. The file permissions come in three different types. There is the R, W, and X. R stands for read, W stands for write, and X stands for execute. And those have slightly different, although related, meaning for files and for directories. For files, the meaning is pretty clear. For directories, if you think of the directory as being a special kind of a file, as I mentioned, that's how it is, the meaning becomes pretty clear as well, right? If you read a directory, it's just listing contents of this directory, so getting all the file names in here. If you write to a directory, it just means creating, deleting, or renaming files. Now, the important thing is changing contents of file is not changing the contents of the directory. So if you don't have write permissions to a particular directory, you can still change the contents of the files in it, but you wouldn't be able to, for example, delete this particular file or rename it. And those permissions are coded in binary, so I'm assuming that you know how binary works. So you can have binary representations, standard decimal representation, and the text representation of those permissions. And this is pretty self-explanatory. Now, if you look here, you will notice that there is a lot more than 3 characters that specify permissions, and that's because when you specify permissions for a file, you want to have different permissions for different users. It would be pretty limiting if everybody would be allowed to do exactly the same thing with the file. So there are some common permission sets. You can specify whatever combination of permissions you want, but it typically doesn't make sense, for example, for the owner of the file to have less permissions than everybody else. So here are some permission sets which are more common than others. It's also important about execute permission that you can specify it for any file, but it only makes sense if the file is actually executable. And that does not mean opened by some application where double-clicked. It means it actually contains instructions for the computer to perform. The command to change permissions is called chmod, which stands for change mode. And you are typically only allowed to do it for your own files, or if you are root, then you can do it for anybody. And you can specify permissions either as decimals, as if you remember the table, or you can specify them using the different kinds of mnemonics that tell you how to modify permissions. There are some additional permissions, set user ID and set group ID, which are especially useful for executable programs. In general, every process that you start will work under the privileges of the calling user. So if you execute the ls command, it will try to do its work based on your permission. So if you're trying to list files in directory for which you don't have read access, it will fail. But sometimes it's important that the programs run under the privileges of program owner, not the calling user. So this is where the set user ID and set group ID permissions come into picture. And then the other more powerful way of specifying permissions is access control list, which gives you much more fine-grained control over it. There are some more file attributes which are potentially interesting, but I will not go into too much details right now. An important concept is links. I've mentioned it before, but I want to come back to it now that you have a better understanding of how file system actually operates. So a link is an additional pointer to a file. It basically means that whenever you create a file, you are putting one pointer in a directory list of files. And then this pointer associates a particular file name with a particular place on the disk, a so-called inode. And in many situations, it's useful to make additional pointers to the same file, and you can also make links to directories. So there are two kinds of links in Linux. One is called symbolic links, which basically says look over there for actual data. So there is a real file and a symbolic link which just tells you where the actual data can be found. Here is an example of how it works. And there are also hard links, which are just additional entries in the directories, which point to the same inode as the original. So then both ways of accessing the data are equivalent. Neither one of them is more important. So here you can see the difference. Another interesting command is the stat command, which displays detailed information about the file. So there is a lot of information that you can learn about a particular file. For example, things like this. And one more thing I wanted to mention in this video is startup files, which are used to give shell and other programs information about you and your preferences. So for example, bash startup file are all those. Those will be executed in different conditions whenever you log in, when you create a new shell, and so on. So you can specify what kind of configurations do you want to use. The sudo command allows you to execute commands as any other user. Typically you'll use it as root. So root is a special user in Linux which can overcome all the regular permissions. So it can do things that are normally not allowed to do. So this is the account you use for installing new software, for changing configurations and so on. And you typically don't want to actually log in as root. You just want to execute particular commands with this level of privileges. And also sudo allows you to specify which commands particular user is allowed to execute as root. So you could have, for example, a user who is allowed to add new users, but is not allowed to remove them, and so on. That's something you could do with the sudo command, but you couldn't do by just giving this particular user the root's password and allowing them to log in as root whenever they want. So this is actually a lot of information, and I'm not expecting you to remember all of it. That's way too much. And there is basically no reason, because there is a lot of documentation that's available about GNU Linux systems. And a lot of it is built in. So there is a command called man, which offers documentation on most GNU Linux commands and configuration files. There is a command called apropos, which searches man pages for particular keywords. So for man, the argument has to be the actual command. If you don't remember the actual command, you can use apropos and then tell some kind of keyword. It will find you commands that are important. So for example, if you don't remember the command to change permissions, if you try to do man permissions, there is no such command. But if you try to do apropos permissions, you will find what you are looking for. There is help command, which works on internal shell commands, so it will not help you with things like change mode or ls, but it will help you with cd, for example. There is command called whereis, which will find command and its documentation. A lot of commands accept the --help argument, so you can use ls --help, rm --help, and so on. And of course, there is Google. It actually knows a lot about Linux. So that's it. I will have some questions from you, hopefully, during the lecture. Thank you very much for watching.